In this presentation, we are going to talk about our next logical operator in propositional logic, that is implication. Now let's consider the definition of implication. What does it really mean? Let P and Q be two propositions. The proposition if P then Q, denoted by P implies Q, is called implication or conditional statement. Please note down this important point. If P then Q is called conditional statement. We know that already, that if then construct is always a conditional statement, right? If P is satisfied, then only we would be able to talk about Q, right? This particular proposition is denoted by P implies Q. This is the symbol we are going to use for implication, okay? Now let's consider the truth table of implication. When P is true, Q is true, then definitely P implies Q would be true. When P is true, Q is false, then P implies Q would be false. But the most important point we need to understand in this truth table is that when P is false, it doesn't matter what would be the truth value of Q, P implies Q would always be true. This is most important point to understand in implication. When P is false, then definitely P implies Q would always be true. We can understand this complicated looking portion with the help of examples. Now, let me emphasize one important point related to implication or conditional statement. P is called hypothesis or premise, and Q is called conclusion or consequence. Here P is called premise and Q is called conclusion. Okay? Now let's consider some examples to better understand the concept of implication. Here is our first example. If you try hard for your exam, then you will succeed. Now let me ask you one question. Is this particular statement a conditional statement or not? This particular statement is a conditional statement because we can see that this particular statement is of the form if P then Q, right? Now let's see what is P and what is Q in this particular statement. Here P is you tried hard for your exam and Q is you succeed. Okay, in order to understand this particular conditional statement in better details, we will consider 4 different cases related to this particular statement. Now let's consider our first case. You tried hard for your exam and you succeed. Suppose you tried hard for your exam and finally you succeed as well. This means P is true and Q is also true, right? This simply means that this whole compound proposition P implies Q would be true, right? Because you tried hard for your exam and you also succeeded. This simply means that this particular statement is correct. Therefore, according to case 1, this compound proposition P implies Q is true. Now let's consider the second case. You tried hard for your exam, but you failed. That means you tried hard for your exam. You did a lot of hard work to prepare for the exam, but finally you failed. This means that P is true and Q is false, and hence the whole compound proposition becomes false. Isn't that so? According to this compound proposition, if you try hard for your exam, then you will definitely succeed. But here, you tried hard for the exam, but you eventually failed, which means that this argument is false, right? Now let's consider case number 3. You haven't tried hard for your exam and you succeeded. Now this is one of the most interesting case we need to understand very carefully. Here P is false, right? This particular proposition P is false. You haven't tried hard for your exam, but your luck favors you and you get succeeded. That means P is false and Q is true. According to the truth table, when P is false and Q is true, the compound proposition P implies Q becomes true. But why? Because you can make the compound proposition false only when you satisfy the first condition itself, that is P. Let's try to understand what does this statement mean. Now, according to this statement, if you try hard for your exam, then you will definitely succeed, right? But you haven't tried hard for your exam. Then how can you come to this conclusion that this particular proposition is false? Try to understand this statement. You can only make this compound proposition false when you make this particular proposition P true. If you satisfy this particular proposition, then only we would be able to argue about this whole compound proposition. Did you get my point? If that itself is not satisfied, then we cannot make compound proposition false, right? Not false means true. Therefore, we can say that this particular compound proposition is true when P is false. You can only argue about this particular statement when you tried hard for your exam. If you haven't tried hard for your exam, then how can you argue about this particular statement? You cannot make this statement false. Let's consider the another case. You haven't tried hard for your exam and you failed. Now we know that P is false and Q is false. Because P is false, we would not be able to make this particular proposition false. Isn't that so? This proposition can be made false when you tried hard for your exam and you eventually failed. But here you haven't tried hard for your exam. If you haven't tried hard for your exam, then you're out of this statement and you would not be able to make this statement false, right? Therefore, this compound proposition is true. Now let's consider one more example to cement this concept. If you have connection with seniors, then you will get promoted. According to this statement, if you have connection with seniors, then you will get promotion. Suppose you have connection with seniors and suppose you will get promoted as well, then definitely this statement would be true, right? This whole compound proposition would be true. But if suppose you have connection with seniors and you will not get promoted, then you will feel like cheated. I do have connection with seniors, but I am not getting promoted. Then you come up with this conclusion that this particular statement is false. Isn't that so? But if you have no connection with seniors, it doesn't matter, you will get promoted or not. You cannot argue about this particular statement, that this statement is false. Let's consider one more example. If you get 100% marks on the final exam, then you will be awarded a trophy. If suppose this is true, and if suppose this is false, then you feel like cheated. Isn't that so? Then this particular compound proposition would be false, right? But if you won't get 100% marks, then there is no point of considering this whole compound proposition. Isn't that so? This particular compound proposition remains true. This is very simple to understand. If you won't get 100% marks on the final exam, then how can you ask for a trophy? If you get 100% marks, then definitely you can demand for a trophy. If you get 100% marks and you're not getting a trophy, then definitely this statement is false. But if you won't get 100% marks, then you cannot demand for a trophy. You may get a trophy or you may not get a trophy. But you cannot say that this particular statement is false. If you won't get 100% marks and you won't get trophy, then you cannot argue that this particular statement is false. Because the initial condition itself is not satisfied. And hence, this whole compound proposition remains true. Now please remember this golden point. If P is false, then it doesn't matter what will be the truth value of Q. P implies Q is always true. Now let's consider the homework problem. Determine whether each of these conditional statements is true or false. If 1 plus 1 is 3, then dogs can fly. If 1 plus 1 is 2, then dogs can fly. If monkeys can fly, then 1 plus 1 is 3. If 1 plus 1 is 2, then 2 plus 2 is 5. If Delhi is the capital of India, then Beijing is the capital of China. You can always post your answers in the comment section below. Okay friends, this is it for now. Thank you for watching this lecture.